This is Geometry, Chapter 7, Section 4, in which we will study parallel lines and proportional parts. Okay. Our first idea is the triangle proportionality theorem. And it's got a lot of prepositional phrases, it's got a lot of things going on for a fairly simple idea. Okay. What we've got going on here is we have a line parallel to one side of a triangle. And that line goes through the other two sides. So specifically in this picture, I'm talking about segment MN. It's parallel to KL, and it's intersecting the other two sides of the triangle. Then this line divides the sides into segments of proportional lengths. So this line breaks these two sides into proportional ratios. That is, JM to MK is congruent to JN to NL, or is equal to, I should say. The ratio on the left is equal to the ratio on the right. That's what the triangle proportionality theorem says. So let's apply this theorem. If we know PS is 12.5, SR is 5, and PT is 15, our job is to find QT. Now, since we have parallel side here, a line parallel to the base, intersecting the other two sides, we can write a ratio. PS to SR equals PT to QT. Substitute in what we know, cross multiply, do a little cleanup work, and then divide, and we get x equals 6. So QT is what we're looking for here, is 6. Now compare that with the triangle proportionality theorem converse. In this case, it's saying to you, if the sides are proportional, then this middle line is parallel. If our ratios work on here, then GH would be parallel to DE. So let's see if it is in this case. DG is half of GF. So DG to GF, they tell me that DG is half of GF. EH to HF, let's see how that compares. 6 to 10, which is 3/5. They're not the same ratio. Since they're not equal, they're not parallel. The ratios needed to be equal for the lines to be parallel. Had this been 3/5 here, or this been 1/2, then it would be yes, they're parallel. Since they're not the same ratio, the two lines aren't parallel. Now, back last chapter when we talked about trapezoids, we talked about the mid-segment of a trapezoid connecting the two midpoints. The same term is used in triangles. If you connect two midpoints, you have a mid-segment. Each triangle has 3. I only drew one in here. DE would be a mid-segment. If I connected E to the midpoint down here, call it F, EF would be a mid-segment, and DF would also be a mid-segment. I only drew one just to not clutter the drawing too much. The triangle mid-segment theorem, 7-7, tells us that the mid-segment, remember connecting the midpoints, is parallel to one side and is also half the length of it. So what we're saying is DE is parallel to BC, and also DE is equal to half of BC. If you were to have to prove that, I would use similar triangles to do the job. let's use the mid-segment theorem here to find some values. Okay. We know up here that the whole side AC is equal to 15. We know this part FE is 9.2, and we know an angle D here, angle BDE, is 82 degrees. All right. Our first job is to find DE. Well, since they're marked as intersecting at midpoints, this is a mid-segment, so it's half of AC. Half of 15 is 7.5. To find the length of DB, first we need to know AB. FE is half of AB. So if this is 9.2, that makes this whole side 18.4. D was the midpoint, so this would be half of it. It will also be 9.2. You could also look at this as a parallelogram. 9.2 would make this 9.2, and since those are congruent, this would also be. And then finally, angle FED is also 82. These lines are parallel. FD and AB are parallel. So these are alternate interior angles. Okay. We have a couple of corollaries that go along with this idea. The proportional parts corollary says if you have 3 parallel lines or more, and they're intersecting transversals, then they cut the transversals proportionally. So in this scenario, this picture, AB to BC would be the same as DE to EF. That's not saying AB is equal to DE. It's saying that the ratio of AB over BC is the same as DE over EF. Now, an offshoot of that corollary is if the lines cut off congruent segments in one place, then they'll cut off congruent segments everywhere. If AB is equal to BC, then DE would be equal to EF. Now again, that doesn't guarantee you AB and DE. It just guarantees you if these two are equal, then so are these two. Okay. So a little bit of work with parallel lines and making proportional parts by using parallel lines to cut off segments. And especially involved in that is the mid-segment of the triangle. If you had questions along the way, hopefully you jotted those down, bring them in to ask, and we'll see you in class.